Welcome. In this demonstration, we are going to see an example of how to use Smartflow to analyze what is happening within a layer 2 or VLAN domain in our environment. This is very useful for working on traffic migrations, studying how traffic switches within the layer 2 domain, analyzing strange behaviors on a port, such as intermittence, and much more. We will perform this analysis over data gathered in time of about 15 days of traffic to understand the behavior of the applications. We will start here by looking at 2 days of such sample of network traffic. So imagine we are in a situation where we have to move traffic from source ports, VLANs to another environment. In this case, we can explore each VLAN of the environment to achieve, for example, an optimal migration strategy. Let's see what layer 2 domains or VLANs we have and where do we find the major traffic components, for example. So we have many VLANs in this set of flow data. Only in this period, we have 190 VLANs moving traffic with about 250 attached interfaces to them. So let's take a look on the amount of traffic present in each VLAN. So we can see here that besides the traffic that is being routed, which has destination of VLAN 0, we have VLAN 200 as the next major VLAN with respect of bandwidth in this environment. So let's take this VLAN 200, for example, to explore its content. We can create a dynamic filter here to just take a look inside this VLAN. Okay, we will pin this across all of our apps, this filter. So we see that this VLAN involves a lot of hosts generating traffic from a lot of different source ports. And here, the type of traffic it contains jumps directly to our view. We see basically that this VLAN main traffic component is network file system transport, which is the destination service, and which is commonly used by distributed systems to run backups. So this is our main traffic component and application. We can then study the dynamics over time. For instance, in this 2-day period, this VLAN has a higher component of traffic in the nighttime, as it jumps to 10 plus gigabytes in nighttime. And this corresponds to peaks of transfers of several gigabytes, mainly at night, and then it cools down, right? We have the one night here in that 2-day period. And well, this is normal as backups are usually scheduled during off hours. So if, for example, we were to be dimensioning a migration, this is very relevant because if I extend this VLAN between two networks, for instances, and leave some ports on one side and the other, I can congest the interconnection links. So I need to be very careful in sizing my interconnections, having this peak traffic in mind, this 10 gigabits peak traffic. Also, we can see which ports are more relevant to this VLAN here. In this relational graph, we see that it seems that ports 22 and ports 37 are the ones that are sending and receiving more flows than the rest, are more interconnected to the rest of the ports in the environment. And we can also see this in the graphic here, in the ports input and output ports of the environment relationship, that the 37 and the 22 seem to be very important for this domain. So this is something to take into account also. Another thing we can see for this layer 2 domain is which servers are receiving the most connections. So let's study this services overview. And we can see for this period of time, for this VLAN, the .38 and the .39 endpoints, which are these two servers, are are the most have the most hits, have the most flows, and that traffic is mostly coming from this host, which is the 49. As we can see here in the traffic components graphs. So these endpoints are also highly relevant while studying what is happening in these layer 2 domains. Lastly, we can take a look at our QoS dashboard here to confirm that this traffic is mostly composed of large frames. This is commonly associated with best effort data transfers. Where packets that use large frames are most commonly best effort traffic or data transfers. So it is important to notice also here that it seems that the markings that this application is using is not well configured in layer 2 and layer 3. Some of the traffic is classified as with marking 0, which is normally best effort, and here we see that in layer 3, some of it is being marked with another class of service. So this is something that probably needs to be reviewed and corrected. So in this simple exercise, we have studied the layer 2 domain, and we reviewed its behavior, applications transported, bandwidth profile, main ports, and frame structure. This type of analysis that is done dynamically and can be done by a consultant to draw conclusions in seconds of what is happening in the environment with the traffic for the VLAN. By collecting traffic flows directly from the equipment and interpreting them and making them available in different views, we can filter and study the environment from the point of view of the traffic itself and gather meaningful insights for network tasks such as migrations and so on. Thanks for stopping by and have a great day.